Dear students, in this lecture, we will discuss about the working of Cochrane boiler. So the Cochrane boiler, which is used for the industries and for the other purposes, and it is studied in the basic mechanical engineering subject for first year. So a Cochrane boiler, it is a vertical multi-tubular and internally fired boiler. It means it is a vertical boiler where the cylinder or the boiler cell is kept as vertical. Multi-tubular means it has a number of multi-tubes inside which the flue gases flow. It is internally fired. It means the combustion occurs inside the boiler. Cochran boiler, it is a fire tube boiler having a number of horizontal fire tubes. So fire tubes inside which the hot gases flows and these are kept horizontally. The maximum evaporative capacity of this Cochrane boiler is 4000 kg of steam per hour. It means it can produce 4000 kilogram of steam per hour, and the maximum pressure that can be kept by this boiler for the steam, it is 10 bar. Now this boiler consists of the different parts, and these parts are, we can say here, there is cylindrical cell, it is a vertical cylindrical cell, and there is a grate and ash pit where the combustion will take place, ash pit where the ash is stored, firebox or furnace where we place the fuel for the combustion purpose, flue pipe through which the flue gases pass, fire tubes or flue tubes. Actually, these are the tubes which gives heat to the water to convert it into the steam. Combustion chamber where the combustion of the fuel takes place, chimney through which the exhaust gases, after supplying the heat to the water, they leave the boiler. Manhole, there is an elliptical hole through which a man can enter for the servicing or repairing purpose, and damper which control the amount of the exhaust gases passing through the chimney. So these are the different basic parts or units of this boiler. Now, in this diagram, we will understand the working of the boiler. So we can see here the different parts of the boiler. So starting from the top, you can see here, this is the steam stop valve. It is used to control or regulate the steam which has been produced by the boiler. There is a safety valve. So there is a spring loaded safety valve which release the steam when the excess pressure is there. Pressure gauge is there. This pressure gauge checks the pressure of the steam. Manhole, there is a provision of the manhole and it is used when there is a need to service or repair inside the boiler. Here you can see there is a water gauge. So water gauge reads or indicates the amount of water level in the boiler cell. On the right hand side, you can see it is the chimney and it is showing the arrow upward. So the exhaust gases pass through this chimney upward. And there is a door which is called as a damper. So by the operation of this door, we can control the amount of smoke passing through the chimney. So this controls the amount of exhaust gases, as well as also we regulate the amount of air inside the boiler, so it controls the amount of steam produced. Here you can see there is a fire break lining. This is the fire break lining. It is provided here so that the heat of the steam should not go outside. So it acts as the insulator. And then you will see this is called the combustion chamber. Actually, hot gases are there, and hot gases pass through this passage inside these tubes. So these all the tubes are for passing the hot gases, and covering the all the tubes there is the water. So the heat transfer actually occurs here from the hot gases to the water, and after giving heat, the all the hot gases through this smoke box go to the chimney and leave the boiler. There is a flue pipe which connects the furnace with the combustion chamber. So you can see here, this is the furnace which is having the hemispherical shape. The purpose of using hemispherical shape is to provide the maximum surface area for which it can absorb the maximum amount of heat which can be transferred to the water. Under this, you can see this is the furnace where we burn the fuel. So actually, this is, we can say, the grate area, and after combustion, this is called as the ash pit. Here the ash is collected. This is the fire door where we supply the fuel for the combustion, and air for combustion enters from this area. So the air moves upward, taking participation in the combustion. On this side, you can see the blow up cock. So when the water is stored in this boiler, there are the sediments of the water which are deposited here. These can be moved out of the boiler with the help of this blow up cock. This furnace of the hemispherical shape, as well as the steam space, is also the hemispherical shape. So to use the maximum volume or maximum surface area, we use these shapes here. This is the door through from which we can operate, we can remove the extra amount of the hot gases here. So these are the all the parts of this boiler. How the working occurs here. So the working is very simple, because in each of the boiler our purpose is to use or to utilize the heat of the flue gases or the hot gases to the water to convert it into the steam. So here we can say the combustion of the fuel takes place at this portion. So when the combustion takes place, it produces the hot gases. Then these hot gases through this flue pipe pass through this area, which is also covered with the firework lining, and these hot gases pass through these tubes, which are called as the fire tubes, and then passing through smoke box, these leaves away the boiler. Then surrounding these tubes, under the tubes as well as above the tubes, there is the whole space is covered by this water. So water is getting heat from this area, and water will be converted to the steam. Then because the steam is lighter than the water, so it occupies this space. Because the boiler is filled only two-third part, the remaining part is open. So this hemispherical dome is filled with this steam. So with the help of this steam step ball, we can use the steam, we can supply the steam to the need where required. We also here use a feed check valve through which the water is supplied in the boiler. So it is made under the downside here. In this way, this boiler works. It is used for the industry. It is not having the much more pressure. So this is all about the working of the Cochrane boiler. Thank you.